In this video, we will go through a 5-step hypothesis testing procedure for the one-sample t-test, and we'll try to calculate everything manually. Let's consider the following example. Where a sample of size 15 is drawn randomly, the population mean or the hypothesized mean is 50. This is a left-tailed test because the hypothesis test includes the less than sign that is under the alternative hypothesis. The sample mean is less than the population parameter, and the significance level is set at 0.05. In step 1, we will develop the appropriate hypotheses for this test. Before developing the null and alternative hypotheses, we need to define the parameter of interest and the claim made about the population. A parameter is a number that describes the whole population of interest. A claim is a statement made about the population in the study or survey using a parameter of interest. In this scenario, the parameter of interest is the population mean and the claim says that the mean of the sample data is less than 50. Now a null hypothesis is defined as the statement of zero or no change. This means the null hypothesis states that the population mean of the sample data is 50. An alternative hypothesis is defined as the statement that is true if the null hypothesis is false. This means the alternative hypothesis states that the population mean of the sample data is less than 50. This is the claim made about the population. Now, in step 2, compute the test statistic, that is the t-statistic. A t-statistic for the one sample mean gives the standardized distance of the sample mean from the population mean. To calculate the t-statistic, use the following formula. Where x bar represents the mean and s represents the standard deviation of the sample data, and n is the sample size. Use the following formula to calculate the sample mean and the sample standard deviation and put these values in the t-statistic formula. We compute the test statistic, t equals -1.95. Now, moving on to the third step of the hypothesis test, we need to find the p-value. A p-value is also known as the probability of making a type 1 error, that is the probability of rejecting the null hypothesis when the null hypothesis is actually true. In this scenario, the t-statistic is -1.95. The t-statistic follows a t-distribution with 14 degrees of freedom and the p-value lies on the left tail of the t-distribution because the alternative hypothesis is left-tailed. In the t-distribution plot, the area under the curve, on the left side of the t-value of -1.95 represents the p-value. In the t-distribution table, first, select a row for the degrees of freedom value of 14. Then select the cells within which the absolute value of the t-statistic, which is the value 1.95, lies. Now select the column values associated with these two cells, which provides the range of the p-value. The p-value lies between 0.025 and 0.05. Now, in the fourth step, use the p-value approach to make a decision regarding the null hypothesis, which says to reject the null hypothesis if the p-value is less than the significance level. Since the p-value is less than the significance level of 0.05, the null hypothesis is rejected. Now, in the fifth and final step, we will conclude the summary of the hypothesis test that is at a 5% significant level. There is sufficient evidence to conclude that the population mean of the sample data is significantly less than 50. Please comment down below if you have any questions relating to this topic.